Moving on, I'll talk about containerization. The data science community that we are living in, the knowledge that we are accruing is predominantly from a machine learning perspective. But the biggest problem is once you develop the application, it has to basically be deployed, right? It has to go into some other system or some other person has to use it. This is a very common problem for any application, not just ML code. This is a common problem for many applications that we have. So what should we do here? If I say, hey, I developed my application in my local machine, I trained it. Flask application also I have developed. In my computer, it is working fine. And I share this entire code to, let's say, the testing team, or probably they say, I'm giving this code to you. You started running this code and you will see a lot of things breaking up. I'm pretty sure everyone has experienced this, right? Some or the other way, there will be some or the other error coming up saying that the package is missing or the version mismatch happening or this is not there or that is not there, isn't it? So the code that we are developing is going to have some functionality issues if the system is changed, right? So what we do when we are trying to deploy is to ensure that irrespective of what is the computer or what is the server or what is the location, basically, the code is getting deployed. If the code has to work without issues as expected as the system was working or the application was working in my computer, I ensure that the code is given in a complete container as a single pod, right? Single entity, which includes everything that is required, irrespective of where you are running, on what platform you are running the code or our applications. So all the dependencies, including your OS dependencies, the Python libraries, the dependency versions, everything that we require is contained within the single application software that we are going to share, right? So we are creating a container, okay? Now this concept is basically given birth to the containerization concept. So containerization is basically a process, a method, which allows us to have OS level virtualization for application deployment or application development. And this concept is predominantly used for running and developing the applications which are getting shared between multiple systems. So it's like testing team is different, development team is different, the production teams is different, right? So development team says, hey, this code is working. Testing team, when they start, they say it's not working for us. Then somehow you fix the issues and testing team is saying, okay, now it is working. They take it to production environment. In production, again, it fails. So there is a lot of these gaps that we'll see, isn't it? So in order to have this issue clarified, the issue removed out of the question, when development team is developing, they give an image, a container to the testing team. They take that image and develop a container using softwares, different softwares, and they use that image and then they can simply start working on, right, the testing part. They don't have to worry about the dependencies, OS level dependencies or some other cross functionalities. Once the testing is done, of course, everything works fine. Then you take that application to production. Again, the image is taken. So this is the right benefit of having your containers. So more than one isolated service, you can have multiple applications. That's what it means. More than one isolated services means I'll have multiple services or applications which can be executed on a single computer without having any cross dependencies and cross functionalities issues. So that is the advantage of having containers. So you're going to say, if this is my server, you're going to create a container. It's like image. This is another image. This is another image. This is another image. So you can create multiple images on the same server, and you can try and deploy those applications. So application containers contain the same runtime components which are required for that code to or the application to run. So everything is bundled together and shared, right? Libraries, Python libraries, you can say, environment variables with respect to operating system or any other dependent files, etc. Everything is bundled together. The concept of containerization, you have to learn about something called as virtualizations to try and understand why containers are more important or why containerization is getting more popularized now. There's something called as virtualization, where we create virtual machines using this concept. So it's like, this is my server. Physically, there is one big server. I'm going to split this logically and say VM1. So if I have 2 cores, 2 CPUs and 16 GB, I can split this into 1 core, 8 GB machine, and another machine is 1 core, 8 GB. So I'm basically restricting, creating boundaries and creating 2 computers from the same server, right? So these are hence called as virtual machines. But the problem here is these are heavy, right? There's a lot of hardware dependencies and all that. Whereas containers doesn't deal with this. They don't kind of split the hardware. They only take application level, right? So if you have 12 GB 2-core system, your containers will work on this only. We are only talking about application level dependencies, right? Not the hardware related. So this is the advantage of having the containers.